Okay, here's the problem solving video for problem 2.82. Says find V0 and V1. We're going to use the problem solving strategy on page 49 again because we have a single source and resistors. And step 1 says systematically reduce the resistive network so that the resistance seen by the source is represented by a single resistor. Let's look at this circuit. For instance, that's usually a confusing connection. Really, we can take and just pull all the connections down to here, okay, because that's a conductor with no resistance, so we can basically pull these 2 points and make them the same. Now let's do that. Let's redraw the circuit. When we do that, so we can see what the circuit will look like. So when we redo that connection, here's what we'd have. Here's a voltage V0, here's 4 kiloohms, 20 milliamps, 10 kiloohms. These are the same circuits. We just eliminated that one connection that has a potential to be confusing. So now what we're going to do is begin to combine these in series and parallel. And once we reduce it down to a source and a resistor, then we'll work our way back. So for instance, these two are in parallel, so let's redraw the circuit combining those in parallel. Okay, so the voltage V0 still appears here. Okay, a 6K and a 12K in parallel is equivalent to a 4 kiloohm. Now the voltage V1, if we look at this circuit, is across this resistor. Okay. Now, if we'd have been very clever, we would have noticed in this circuit that the 6K, 12K, and this 4K are all in parallel. Doesn't make any difference because now the two 4Ks are in parallel. Okay, so the two 4Ks are in parallel. So now when we do that, that will combine down to a 10K. So the two 4Ks in parallel is a 2K. So our circuit reduces to this. Now, those two resistors in series. So the two 4s combined into a 2K. They're now in series with a 10K. Now, if you notice, this is still the voltage V1. Okay, so now let's combine those. And when we do that, our circuit will reduce to the following. We'll have 12 kiloohms, 4 kiloohms, 20 milliamps. Okay. Now V1 is gone from this circuit because we combined the 10K and 2K in series. And if we wanted to combine this down to a single resistor, it would be 20 milliamps, 3 kiloohms, and that would be our circuit. Okay, now, So that gets us down to complete step 1. Step 2 says determine the source voltage. Okay, well that's easy. The source voltage is 60 volts. Okay, so this voltage is 60 volts. So that tells us by Ohm's law that current's 15 milliamps. This current is 5 milliamps. Okay, so now we're going to start backing back up through our circuit. Okay, here this is 15 milliamps. This is 5 milliamps. Okay, so now V1 is 2K times 5 milli, or 10 volts. Okay, so there's V1. Okay, so V1 is 10, and if we note from our diagram, we also had V0, and we really had in an earlier circuit, but if we look at this circuit, we'll notice, for instance, that the voltage across this resistor is 60 volts by Ohm's law. Okay, so V0 here is minus 60, and that's because V0 has the opposite polarity of that voltage. We really also had V0 calculated here, because there's V0, and in fact there's V0 is across the circuit here. So again, we can see from any of those we could have calculated V0, but we can get it from that circuit there for sure.